Chapter 6, Techniques of integration and the integration by parts. Suppose that u of x and v of x are two differentiable functions del over del x ux times vx, it equals to ux times del v over del x plus v of x times del u over del x, okay, and the integral u of x times del v over del x times del x. This part is cancelled. It equals to u of x times v of x minus integral e of x times, okay, del u over del x times del x, okay, and the equals to integral u times del v equals u times v minus integral v times del u. This is the integration by parts general formula. Example, evaluate integral x times e to the x del x, okay, and the firstly choose x by u, and the e to the x del x is del v, okay. So let u equals to x and the del v equals to e to the x del x, okay. So we know that integral x times e to the x del x, that means integral u times del v, it equals to, we know that u times v minus integral, okay, v times del u. We need now, okay, and the del u and the v, okay, and we can find if u equals to x, we know that del u equals to del x, okay? And we know that if del v equals to e to the x del x, so integration of these two parts, you will obtain v equals to e to the x, okay? And we will use these two rectangle formula, and after that u times v, we know that x times e to the x minus integral v, which is the e to the x, and the del u is del x, so it equals to x times e to the x minus e to the x, okay, plus integration constant, so e to the x parenthesis x minus 1 plus c. Another example. Evaluate integral ln x del x, okay, and let u equals to ln x, and del v equals to del x, and after that, if u equals to ln x, we know that del u equals to, okay, del x over x. If del v equals to del x, so v equals to x, and the integral ln x del x, okay, it is u, and that is del v, it equals to u times v minus integral v times del u equals to ln x times x, okay, and the minus integral, okay, x times lx over x, and these parts will be cancelled, of course, and the x ln x minus x plus c, which is the integral of ln x. Example, evaluate integral x squared sin x del x, and the u equals to, let u equals to x squared, okay, and the del v equals to, okay, sin x del x, okay. How can we decide to get the u values? Okay, I will give you small formula. Okay, that means logarithmic, and the arc trigonometric, and this is the polynomial and trigonometric, and the power or exponential. Okay, that means, okay, this order, how you will decide to selecting by u. Okay, if you see logarithmic function, yes, you can choose u by the logarithmic function firstly. Okay, and for example, on this example, as you see, x squared is polynomial function and the sin x is trigonometric function. Which is first? Of course, polynomial function is first comes, so we choose u by x squared. Okay, and if u equals to x squared, and the del u will be 2x del x, and the v will be, okay, and the minus cosine x, right? And after that, integration by parts formula, integral x squared sin x del x, it equals to u times v. What was that? And the x squared times minus cosine x minus integral v times, and the v was minus cosine x, and the del u, which is the 2x del x. Okay, and after that, we know that this part equals to, okay, and the x squared, okay, minus x squared cosine x plus integral, okay, and the cosine x 2x del x, right? And after that, this is total integral. We must, okay, repeat the integration by parts, okay, and so choose the x value by the, let me reorganize this, okay, firstly, and after that I will minus x squared cosine x, okay, and the plus 2 times x, okay, cosine x del x. Okay, this is polynomial function, so u can be that and the del v can be that. So after that, if u equals to x, okay, and we know that the del u will be del x. If del v equals to cosine x del x, so v equals to sin x, okay, and the integral equals to minus x squared cosine x, okay, plus 2 times, okay, u times v, that is the x times sin x, okay, minus integral v times, which is the sin x, and the del u, which is del x, okay, and it equals to minus x squared cosine x plus 2 times x sin x, okay, and the integral sin x equals to, okay, we know that minus cosine x, so minus times minus cosine x, it will be plus cosine x, okay, and the plus c1, and it equals to minus x squared cosine x plus 2x sin x plus 2 cosine x plus 2c1, it equals to, okay, c, which is the integral x squared sin x del x. example, evaluate integral x times inverse tan x del x. Okay, as you see now, inverse tangent x will be u because this is the arc trigonometric function. Okay, so if u equals to inverse tangent x, so we know that del u will be, okay, 1 over 1 plus x square del x, and the del v equals to x del x, so v equals to x square over 2, right? And the I equals to, okay, u times v, and it is the x square over 2 times arc tangent x, okay, and the minus integral, okay, v times, which is the x square over 2 times del u, which is the del x over 1 plus x square, okay, and the x square over 2 arc tangent x minus, okay, 1 over 2 integration, okay, and the 1 minus 1 over 1 plus x square del x, and it's equal to x square over 2 arc tangent x minus 1 over 2x, okay, and the plus 1 over 2 arc tangent x plus c, okay, and the equals to 1 over 2 parenthesis, okay, x square arc tangent x minus x plus arc tangent x plus integration constant. Another example, evaluate the inverse sin x del x, okay, and we know that the let u is equal to inverse sin x, okay, and the del v will be del x. If u equals to inverse sin x, so del u will be, okay, 1 over square root of 1 minus x square del x. If del v equals to del x, v will be x, and the integral inverse or arc sin x del x equals to u times v, okay, x times, okay, arc sin x minus integral v times del u, which is the del x over square root of 1 minus x square, okay, and after that what will we do? Okay, we will substitution rule, we will use the substitution rule, and which is the u equals to 1 minus x square, so del u will be minus 2x del x, okay, and after that I equals to x times inverse sin x, okay, and plus 1 over 2, okay, integral u to the power of minus 1 over 2 del u, and x times arc sine x plus 1 over 2 times, okay, 2 times u to the 1 over 2 plus c, and the inverse x times arc sine x plus, okay, and the u was square root of 1 minus x square plus c. Example again, and this is very interesting example, I think. Evaluate the integral secant cube x del x, okay, I equals to integral secant cube x del x, it equals to integral secant x times secant square x del x. Okay, firstly we'll choose secant x by u, and this part will be del v, okay, and let u equals to secant x, so del u will be secant x tan x del x, and the del v equals to secant square x del x, okay, so b equals to tangent x, right, and we will use this blue rectangle equality, and the I equals to u times v, which is the secant x times tangent x, minus integral, okay, v times del u, which is the tangent x times, okay, secant x tangent x del x, okay, and the secant x tan x minus integral secant x times tan square x del x, okay, and the secant x tan x minus integral, okay, and the secant x parenthesis secant square minus 1 del x, and the after that secant x tan x minus integral, okay, and the secant cube x minus secant x del x, okay, and the secant x times tangent x, okay, and the minus integral secant cube x del x, okay, and the plus integral secant x del x. My friends, please attention, this part is our question, which is this part, and we can write this is I, okay, and continue. So this I comes to here, and here will be 2I equals to secant x times tangent x, okay, and the plus integral secant x del x, and the 2I equals to, okay, secant x tangent x, okay, and the plus ln absolute secant x plus tangent x, okay, and it equals to 1 over 2 secant I equals to 1 over 2 secant x tangent x plus 1 over 2 times ln absolute secant x plus tangent x plus c. Okay, and this is the total integral. Example again. Evaluate the integral from 1 to the e, okay, and the x cubed times ln x square del x if u equals to ln x square, and the del u will be 2 ln x times 1 over x times del x, okay, and that means that 2 ln x over x del x, right? And the other part, if del v equals to x cubed del x, so v equals to x to the 4 over 4, okay, and the integral from 1 to the e x cubed times ln x square del x, okay, we know that the ln x square is u and the other part is del v, so u times v, and the x to the 4 over 4 times, okay, ln x square, and the minus integral v times del u, and that part is x to the 4 over 4 times 2 ln x over x del x, right? And this part will be cancelled like that, and of course this part will be 2, and some simplification, and the x to the 4 over 4 times ln x square minus, okay, maybe this part you can evaluate, okay, and from 1 to the e, and the other part is minus 1 over 2 times integral, okay, here is 1 to the e, of course, integral from 1 to the e, okay, and the x cube ln x del x, right? And for this part, okay, this is u, and this part is del v. So if u equals to ln x, we know that del u equals to del x over x, and if del v equals to x cubed del x, so v equals to, okay, x to the 4 over 4. So the first part, for this part again, e to the 4 over 4, okay, and times ln e, it will be 1, okay, 1 square, and minus the other part will be 0 because ln 1 equals to 0, and the minus 1 over 2 times, okay, and the u times v now, it will be again x to the 4 over 4, okay, and the ln x, but this time not ln x parenthesis square, okay, and the minus integral, of course here 1e, integral from 1 to the e, okay, and the v times del u, and we know that x to the 4 over 4 times del u is ln x, I'm sorry, not ln x, del x over x, of course, and the cancellation again, and this part, and the e to the 4 over 4, okay, and the minus 1 over 2 parenthesis x to the 4 over 4 ln x from 1 to the e, okay, minus 1 over 4 integral from 1 to the e, okay, and the x cube del x, right, and it equals to e to the 4 over 4 minus e to the 4 over 8 plus 1 over 8 times x to the 4 over 4 from 1 to the e, okay, and it equals to e to the 4 over 8 plus e to the 4 over 32 minus 1 over 32. So integral from 1 to the e, okay, x cubed times ln x square del x, it equals to 5 over 32 e to the 4 minus 1 over 32. Okay.